We look up at the night sky and believe we see the entire universe. But the brilliant stars are just the foam on a deep ocean. Beyond the shimmering lights and swirling gas clouds lies a profound mystery, an invisible architect that holds everything together in the vast, cold reaches of space. Scientists have discovered that all the matter we can see, every star and planet, accounts for only 5% of the total mass of the universe. The rest is a hidden scaffold, a dark matter skeleton that makes up 85% of the cosmos, remaining completely invisible to our most powerful telescopes. This is the greatest ghost hunt in the history of physics. A quest to find a substance that does not emit, reflect, or even block light. For years, the brightest minds have stared into the darkness, searching for clues about this elusive phantom that dictates the destiny of our entire cosmic home. It all began with the dawn of time, when the Big Bang cast the seeds of both light and shadow across the infinite, expanding canvas of reality. These dark veins grew faster than ordinary matter, creating a gravitational trap that pulled gas and dust together to form the very first stars and galaxies. Without this invisible framework, the universe as we know it would never have formed, leaving only a thin, cold gas drifting forever in the lonely dark. We are essentially living in a house built by an architect we cannot see, walking through rooms defined by walls that have no physical substance at all. To understand our origins, we must confront the darkness, diving deep into the secrets of the most mysterious component of our strange and wonderful celestial clockwork. Every motion of every star is a clue, a silent testimony to the power of the unseen forces that govern the laws of nature and gravity. Welcome to the mystery of dark matter, the invisible force that holds the keys to the past, the present, and the ultimate fate of our universe. The story takes a sharp turn in the year 1970, inside a quiet office where a woman made a discovery that shocked the scientific world. Vera Rubin, a pioneer in astronomy, began measuring how fast galaxies spin, expecting to find the same patterns we see in our own small solar system. What she found was impossible. The stars at the very edge of galaxies were moving just as fast as the stars near the bright, dense center. According to the known laws of physics, these outer stars should have been lagging behind, drifting slowly like the distant planets in our solar system's orbit. Think of a spinning ceiling fan. If it spins too fast and the blades aren't attached firmly, they will fly off and shatter against the walls. Rubin realized that galaxies were spinning so fast they should have torn themselves apart long ago, scattering their stars into the empty void of intergalactic space. Yet, they remained perfectly intact, held by a mysterious, unseen grip that provided the necessary gravity to keep the entire structure from collapsing into chaos. In our solar system, gravity weakens with distance, which is why the inner planets race around the sun while the outer ones crawl in slow motion. But in a galaxy, the rules seem to change, suggesting there was much more mass hidden in the darkness than what the telescopes could actually detect. Rubin proposed that every galaxy is embedded in a giant halo of dark matter, a massive cloud of invisible substance that provides the missing gravitational pull. Her work was met with skepticism at first, as it challenged the very foundation of how we believed the universe was structured and how gravity worked. But as more galaxies were measured, the evidence became undeniable. The visible light was just a tiny fraction of the total weight of the cosmos. Something was there, something heavy and powerful, acting as the cosmic glue that keeps the giant islands of stars from dissolving into the darkness of space. As Andrea Ghez points out, we are forced to conclude that most of the universe is made of stuff that we simply cannot see or touch. This realization shifted our perspective from a universe of light to a universe dominated by a dark, silent majority that we are only beginning to understand. The invisible hand of dark matter is not just a theory. It is a mathematical necessity required to explain the very existence of the galaxies themselves. Without this hidden mass, there wouldn't be enough gravity to pull matter together to form stars, planets, or even the building blocks of life as we know it. We are essentially passengers on a small, bright boat sailing across an enormous, dark ocean that we can only sense through its powerful, hidden currents. To find this hidden ocean, scientists had to look for the ways it bends the path of light itself, acting as a giant lens in space. Even though dark matter doesn't emit light, it possesses mass, and mass curves the fabric of space-time, forcing light to follow a bent, curved path. This effect, predicted by Albert Einstein, is known as gravitational lensing, and it allows us to see the invisible by observing how it distorts the visible. When a massive clump of dark matter sits between us and a distant galaxy, it acts like a giant magnifying glass, warping the galaxy's image. It is much like looking at a light through the stem of a wine glass, where the image is smeared into beautiful glowing arcs and circles. By mapping these distortions, astronomers can calculate exactly how much dark matter is present and where it is concentrated, even if they can't see it. One of the most famous proofs is the Bullet Cluster, where two groups of galaxies collided, leaving their visible gas behind while the dark matter moved on. The visible gas crashed and tangled like a cosmic traffic jam, but the dark matter simply glided through, unaffected by anything except the pull of gravity. This clear separation between the seen and the unseen was the smoking gun evidence that dark matter is a real physical substance, not just a mistake.
The presence of mass,
as Kip
any
Thorne
mass at all,
explains,
causes this
the
fabric
very
to
geometry of the
Think
universe
space-time
is
as
shaped
this
by this
flexible
hidden mass,
fabric. When an object
bending
with
the
mass
very
rests
stage
upon
upon
it, the
which all
fabric
light
warps
travels.
and curves.
The more mass there is, the deeper the curve, and dark matter provides the majority of the weight that bends the cosmic fabric into its shape. Sometimes this lensing can even create multiple images of the same object, appearing in different parts of the sky at the exact same time. It is a cosmic mirage, a trick of the light played by the invisible giants that roam the depths of space, guiding our eyes across the void. These bridges of dark matter connect the universe, creating a vast highway for light and matter to follow across billions of miles of empty space. By studying these distortions, we are effectively using the dark matter as a natural telescope, peering further into the past than ever before possible. Every peak represents a hidden reservoir of mass, a silent anchor that keeps the galaxies from drifting away into the lonely, cold expanse of the universe. The light of the entire cosmos carries the fingerprint of this dark architect, revealing the secret structure that underpins every star we see at night. We are finally seeing the skeleton of the universe, the invisible framework that has been hidden from our sight for billions of years since the beginning. This discovery leads us to a new understanding of the large-scale structure of the cosmos, where everything is connected by a dark, intricate, and beautiful web. Welcome to the cosmic web, the largest structure in existence, designed and built by the invisible hands of dark matter over billions of years of time. On the largest scale imaginable, the universe doesn't look like a random collection of stars, but like a complex, organized network of light and shadow. These filaments are made of dark matter, and they act as the cosmic scaffolding that directs where galaxies and stars are allowed to grow and thrive. Dark matter is like the steel giardinias of a massive skyscraper. The stars and gas are just the paint and glass that make the building visible. Without the steel frame, the building would collapse. Without the dark matter, the galaxies would have never gathered to create the wonders we see today. Shortly after the Big Bang, dark matter began to clump together under its own gravity, creating deep gravitational wells that acted as traps for ordinary gas. As the gas fell into these dark valleys, it became dense enough to ignite, giving birth to the first generation of stars that lit up the darkness. Each galaxy is born in a dark matter cradle, nurtured by the gravity of an invisible parent that will guide its evolution for billions of years. John 11 explains that dark matter is the master architect, defining the shape and size of every galaxy, from the smallest dwarfs to the largest spirals.
Our models for galactic evolution.
It provides the
This
extra
simulation
gravitational
clearly
torque needed to
demonstrates
maintain
how the
those beautiful
distribution of
spiral
dark
arms,
matter dictates
preventing
the
them from
structure of the
winding up and
galactic
disappearing
arms.
into a featureless, blurry disk. While dark matter pulls things together, it also leaves behind vast, empty voids, huge bubbles of nothingness that dominate the volume of our expanding cosmic home. Everything is in motion, flowing along the invisible rivers of the cosmic web, drawn toward massive concentrations of dark matter that we are only starting to map. Supercomputer simulations that include dark matter perfectly match the actual distribution of galaxies in our sky, proving that our invisible architect is very real. If we remove dark matter from these digital models, the universe they create looks nothing like our own, failing to produce the clusters and structures we see. This invisible force has been the primary driver of cosmic evolution for 13.8 billion years, shaping the past and dictating the future of everything. When galaxies collide, their dark matter halos merge first, setting the stage for the dance of stars that will eventually form a new, larger galactic home. Even our own Milky Way is connected to this vast network, part of a cosmic family tree that spans the entire breadth of the observable universe's reach. It is the shadow of gravity, always present but never seen, a constant companion to every atom of our bodies and every photon of light in space. We are finally learning to see the unseen, to appreciate the beauty of the darkness that makes the light of the stars possible in our universe. But mapping it from space is not enough. To truly understand what dark matter is, we must try to catch a single particle here on Earth. To catch a ghost, you must hide from the noise of the world, going deep underground where the surface radiation cannot interfere with the delicate search. A mile beneath the surface, scientists have built the most sensitive detectors ever conceived, shielded by thousands of feet of solid rock and Earth's heavy crust. This is the LUX-ZEPLIN experiment, a massive vat of liquid xenon waiting for a single, tiny interaction from a particle of dark matter passing through it. Scientists believe dark matter is made of WIMPs, particles so ghostly they can pass through an entire planet without touching a single atom of matter. But very rarely, one might hit the nucleus of a xenon atom, producing a tiny flash of light that can be detected by ultra-sensitive light sensors. These sensors are so powerful, they can detect a single photon, the smallest unit of light, from across the entire volume of the massive, cold tank. Days turn into months, and months into years, as researchers wait in the silence of the deep Earth for a signal that has never been seen. It is a test of patience and precision, where even the tiniest bit of natural radioactivity can ruin a billion-dollar search for the secrets of the cosmos. Right now, trillions of these particles are passing through your body every second,
The difficulty lies in the scale.
and yet you feel nothing,
We're looking for something
as they
so
exist in a
minuscule,
different
so
world.
barely
As
physical.
Rainer Weiss notes, we are trying to measure an interaction so faint it is like trying to hear a single pin drop during a heavy thunderstorm.
Look at the spike right here.
By shielding
It's
the
too sharp to
experiment
background
deep
noise.
But the error
underground,
margin on the sensor
they
line
filter
is
out the
high.
Wait, zoom in
background noise
closer.
of the
That pattern
universe,
matches the simulation
creating a
without
perfect
decaying. The energy
silence
spike is
where the
clearly
dark
outside
matter
the
might
expected
speak.
parameters.
But the calibration data suggests
Every
a system
anomaly
error.
is
I'm getting
checked
the
and
same reading on the
rechecked,
secondary
as
monitors.
the discovery
real.
of even one dark matter particle would rewrite every physics textbook in existence across the world today. If WIMPs don't exist, perhaps dark matter is made of something even lighter, like Axions. theoretical particles that can turn into light in strong magnetic fields. This search uses some of the coldest places in the universe to listen for the faint echo of dark matter interacting with our modern electronic world. Meanwhile, in Switzerland, the Large Hadron Collider is trying a different approach. Instead of catching dark matter, they are trying to create it from pure energy. If they see energy disappearing into nothingness after a collision, it could be the signature of a dark matter particle escaping into the unknown void of space. From the depths of mines in Italy to the ice of Antarctica, humanity is surrounding the problem from every angle, determined to uncover the hidden truth. We are fishing in a dark ocean, using the most sophisticated hooks and bait ever built, waiting for the moment the line finally goes taut and firm. Even if we find nothing, the search itself pushes the boundaries of technology and human knowledge, teaching us more about the fundamental nature of our reality. The hunters are ready, the traps are set, and the stage is prepared for the greatest discovery of the 21st century in the realm of science. The answer could be just one collision away, hidden in a single flash of light deep beneath the surface of our busy, noisy, and bright planet. But as we search for the particles, we must also look at the bigger picture, where dark matter might be even more mysterious than we imagine. Imagine standing outside a stadium, hearing the roar of the crowd and seeing them react, but being unable to see the players or the ball itself. You can still figure out the game is baseball just by watching the crowd. This is how we study dark matter, by watching the stars' reactions. Some scientists wonder if dark matter is hidden within black holes, or if it is made of primordial black holes formed just seconds after the Big Bang. These invisible giants could be the source of the extra gravity, hiding in the one place where light cannot escape and where our physics begins to break. With new tools like the James Webb Space Telescope, we are looking back to the very first galaxies to see how dark matter shaped them in infancy. A new generation of thinkers is coming of age, armed with data that Vera Rubin could only dream of, ready to solve the ultimate cosmic riddle. We are on the verge of a revolution in physics, one that might reveal that everything we know is just a small part of a much larger story. Dark matter is not just a problem to be solved. It is an invitation to explore a hidden side of reality that is more vast than we can imagine. It reminds us that we are still explorers, still the same curious species that once looked at the stars and wondered what lay beyond the campfire's light. Our journey has taken us from the caves to the moon, and now it takes us into the heart of the invisible forces that build our entire world. We are made of star stuff, but we are held together by the dark, a poetic balance between the light we can see and the shadow we can feel. The hunt for the invisible architect is the hunt for our own origin story, a quest to understand why there is something rather than nothing in the void. Every time we solve a piece of the puzzle, we find 10 more questions, leading us deeper into the beautiful, dark heart of the infinite cosmic mystery. The laboratories will stay quiet. The telescopes will keep watching, and the human spirit will continue to dream of the day the darkness finally speaks its name. We are a small, bright point of awareness in a universe that is mostly hidden, a light that refuses to be extinguished by the vastness of the unknown. One day, we will map every filament and every particle, turning the dark universe into a home that we fully understand and finally feel at peace within. Until then, we will continue to look up with wonder, knowing that the most important things in the universe are often the things we cannot even see. The hunt for dark matter is the ultimate testament to human curiosity, a journey that has no end, only new horizons and deeper truths to find. Thank you for joining us on this journey into the shadows, where the invisible architect continues to weave the fabric of everything we have ever known. Keep searching, keep questioning, and never stop looking into the darkness. For that is where the most beautiful secrets are often hidden from our sight. The hunt for dark matter continues, and the answer may finally reveal our true place within the grand, invisible design of the infinite, ever-expanding universe.